Hello everyone and welcome to the webinar. Thank you for taking time out and being here. I'm Khalil, manager with Battle River Research Group. First of all, I would like to thank Beaver County for sponsoring this event. Please note that we will be running a chat room and in the end of the webinar. So we enable the chat room features on your screens. I hope everyone can find it. So if you have any questions, just pop up them in there. And if you miss anything, do not worry. We will be posting this webinar on our website. So you can watch those recordings. They'll be available to you. So today our speaker is Steve Kenyon. He runs a custom grazing business in Alberta under the name of Green Pastures Ranching Limited. He's currently run just over 1,200 head of livestock and 3,500 acres of leased land with regenerative grazing management. Steve has been teaching in schools and doing seminars on regenerative management for more than 13 years. He has been a key speaker at many conferences throughout Canada and US. He is a writer for Stockman Grass Farmer magazine and also for the Canadian Cattleman magazine. Welcome, Steve.
Thank you very much, and thank you everybody for attending. We are going to try and get through this today. I got a few topics we're going to hit, all on regenerative grazing. So we're going to look at the why and the how. Okay, so our company, a little bit about us, is Greener Pastures Ranching. We are a custom grazing operation. One of the biggest parts of our business is comes from our mission statement, and that's here on the screen: economic and environmental sustainability for generations. Very important to us to maintain our environment and maintain the water cycle, the biodiversity. That's a big part to our farm. So we won't get into too much detail on that, but that's what guides us and drives our operation. Why are we not clicking? There we go. So if you're here today looking for a recipe, I'm not going to give you one. Our agricultural industry is hooked on recipes. Farmers want them. They want to know, do this, 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 and this, and you'll get this. And that's not what regenerative agriculture is about. So we just want to make sure you know that you're not getting a recipe here today. Because the problem is the recipe's not working. What we need is to have long-term solutions to the problem. Agriculture is addicted to quick fixes, right? We've got simple solutions to solve a symptom. There's a big difference between a problem and a symptom on your farm. The symptom arises because the problem is there. But we keep addressing symptoms, a chemical or a product or something to address a symptom. The symptom will keep reappearing if you just address symptoms. So what we need to do is look at problems and address the problems. So that's what regenerative agriculture really does, is we address problems in our environment. Okay? So one of the biggest problems we have in our system, and this is not technically on topic from what we're going to talk about today, but I include it in just about every presentation I do now. Biggest problem we have in agriculture right now is this graph. If this is a study a few years ago by Darren Qualman. He's out of Saskatchewan, and he did a Canadian net farm income over 90 years, 1926 to 2016. The top of the blue on the graph is total net farm income for Canadian farms, and the top of the green is the percentage the farmer gets to take home. So does anybody see anything wrong with this graph? We need to fix this. This is our issue as farmers, and we can solve this. We can choose where to spend our money and how much to spend on what. The biggest problem is of marketing and industry, and everybody is pushing stuff on us all the time. When we start addressing problems, then we don't need all these symptom solvers. Okay, So I won't get into too much more detail on that, but that is the biggest issue that I need to solve in agriculture, is how I look at it. What we need is a new light bulb. I heard a phrase here a while ago. It's a very old phrase. Basically, the light bulb was not invented by incrementally making the candle brighter. Okay, we didn't get a little bit brighter, you make that candle a little bit bigger, and then all of a sudden, boom, we had a light bulb. It was a totally revolutionary idea. And that's what we need to do in agriculture, because agriculture is not working. From that graph, you can see that it is not working. This does not work for the farmer whatsoever. So we need something totally new to help solve this problem. Okay. The answer is under our feet. We need to manage our soil. Agriculture keeps adding amendments. We keep this, adding products and fertilizers and chemicals and trying to solve this with technology, solve it with, something new invented. When really all we have to do is go back and manage the soil the way it's supposed to be managed. So that's what we're going to do. So how do we build soil? I'm going to look at two main processes today, photosynthesis and exudation. Two processes that we work in agriculture, and very simple to do, very simple to understand. Photosynthesis is the plants taking carbon out of the air. Okay, it uses the sun. We don't have to really know anything about it. It does it all by itself. So we need to take the carbon out of the air and then build the plants. From there, exudation takes over. Once the glucose is formed by the plants, now as the roots grow, they actually push out some of that sugar out through the root tips and add carbon to the soil. Okay, so photosynthesis takes it from the air and puts it into the plant, and exudation takes it from the plant and puts it into the soil. That exudate, they call it, or from the exudation, is actually like a glue. It glues the soil particles together, the silt, sand, and clay. Now we start putting this sugar, this organic matter in and gluing it together. We get good aggregation, we get good water holding capacity, we build pore space. Very powerful if we can get that working in a positive manner. So that's all we're trying to do in regenerative agriculture is, do more photosynthesis and do more exudation, and we can build soil. Okay, here's a picture. Somehow it's not switching on me, sorry. So here's a picture at our place. I just took a backhoe down here. I don't know if you can see my mouse on here, but there's triangles coming down here that are darker in color in this soil. There's two of them that you can see very distinctly. So that was a root system coming down, and we don't have very much topsoil. Like, we're gray wooded soil in our environment. Whatever topsoil I have, I've built. It's basically clay. And these triangles coming down, the root system has come down and it's been pushing exudate out and basically converting that clay into soil. We're not necessarily growing it on top. We're converting whatever our base is. So if you have a silty soil or a sandy soil or a clay soil, it doesn't matter. What we need to do is pull carbon out of the air through photosynthesis, put it into the soil through exudation. That's what we're trying to do. So you can see it in that photo. So there's a question that a lot of people ask is how plants grow. Little basics here is every plant, whether it's a tree, a weed, a desirable plant, a legume, whatever it is, on a dry matter basis, it has approximately 45% carbon, 45% oxygen, 6% hydrogen, and 1.5% nitrogen. So that's 97.5%. Okay? Every plant. Every other element in a plant is less than 1%, and usually it's measured in parts per million. So a very small amount of that plant, 2.5%, comes from the soil. Carbon, oxygen, hydrogen, and nitrogen all come from the air. So plants, one of the issues that agriculture has is they believe that plants grow from the soil. regenerative agriculture, we say that the soil grows from the plants. That's a big difference. We're looking at it from a completely different angle because that's what we're doing. We're growing the soil. We're using the plants to pull carbon, oxygen, hydrogen, and nitrogen out of the air. And we're trying to, through exudation, put it into the soil. So we're actually growing our soil from the plants, not the other way around. Modern agriculture has it backwards. Okay. So how do we grow soil? Number one is through that exudate. The picture here is a couple of samples. One, this was through our land where we had our carbon sequestration study done over the last 3 years. So we took these soil samples of the land that we were managing, which is the one on the left, and the land that our neighbor managed, which is the one on the right. So ours was under regenerative agriculture for about 12 years. And previous to that, they were managed the same, both continuously grazed. So very similar backgrounds, very similar topography, and that was the difference. So number one, we're trying to use that exudate and put it into the soil through growing those plants. Number two is a term called glomalin. Now this is the mycorrhizae fungi, which is a fantastic organism in the soil that partners with the plants. They actually bind or join together with the roots of the plant and assisted in bringing it nutrients and water and all sorts of things. It's a tremendously beneficial plant in our soil, or sorry, organism in our soil for the plants. And it takes the exudate from the plants, the sugar that they push down there, and they can actually convert that carbon from it into glomalin, which is stored in the soil and is a much more stable form of carbon in the soil. Once it's there, it's very hard to break down. So that mycorrhizae fungi is a huge benefit to adding that carbon to the soil. So kind of an extension of the exudate. We can also leave residue. You can see on the picture there's a little bit of thatch layer in the top of the one on the left, probably about a half an inch deep there. There's some thatch layer. Now this is residue left, dead plant material left on the top. We can grow soil that way, but it's a lot slower and it's a lot more volatile. It can break down and basically be returned to the air a lot quicker. The big reason I would leave residue on top is actually water holding capacity, not necessarily to build soil. What I'm trying to do is build soil with the root systems. And number four is root decay. So as those roots grow down, they'll die eventually, right? With every grazing, we slough some roots off, and at the end of the season, we lose some root systems, and all that carbon has been put into growing roots then starts to break down and goes back into the soil. So that is also a way that we're putting carbon in the soil by decaying the roots. So very simple regenerative agriculture. That's what I'm trying to do, is build this soil. That's my goal. I use the plants to build the soil. Actually, hold on a second. I lost my chat in case somebody was asking a question. There we go. All right. So one of the issues we have in modern agriculture is that everybody wants to add fertilizer all the time. It's not about adding fertilizer. Like I said, 97.5% of every plant comes from the air. That's the most important, resource of nutrients for us. What we need though is biology. We need to build biology, and that helps us get all those nutrients that we need. The mycorrhizae fungi, the bacteria, the organisms. That's a huge part of our farm is building an ecosystem to get the fertilizer for us. We don't have to add fertilizer. Actually, adding fertilizer is detrimental to the biology. We need to allow the organisms in the soil a healthy environment, and they'll get you all the fertility you need. Right? We've got some really fantastic pastures out there, and we haven't used any fertilizers in over 20 years. So it can be done. We just need to build the biology, and they'll get it for us. So soil grows from the plants, not the other way around. 85 to 90% of plant nutrition is microbiotically mediated. We don't have a fertility issue in agriculture. We have a biological issue. We need to build healthy soils. Most of our agricultural land is dead because of all the inputs that we throw out there. The chemicals and the fertilizers that we throw out there is very detrimental to the biology. So the more you put out there, the less biology you have, the more you're going to need to add more. So we keep doing this, you know, adding these symptom solvers, trying to deal with symptoms, when the problem is really we have a biological, a lack of biology. So to get fertilizer, you need to build biology. To do that, we need a polyculture of plants, one species of root system, or one species of plant doesn't get you very much biology. The more variety in plants you have, you'll have a different variety of different types of root systems, which will get you a huge variety of different types of soil life. And that's when the fertility kicks in. So we need that polyculture of plants to get the polyculture of roots to get the polyculture of soil life. And then we're moving forward. A monoculture is ugly. Okay, I'll tell you that right now. A monoculture is very ugly to the biology. They don't like it. They need a variety to integrate, to have symbiotic relationships with all the different biology that's in there. We need a multitude of different plants in our pastures. This is, I mean, that's similar in a crop system or a hay system too, right? The more biodiversity we have, the better. So why are we going to do this? What we're going to get out of this is we're going to improve our water holding capacity. We're going to improve the water cycle, basically. One of the biggest issues we have on our planet right now, in my opinion, is that we have a broken water system worldwide. That water cycle is broken. The droughts, the floods, the fires, the mass storms, all of this, I believe, is caused because we have a majorly damaged water cycle. If we could get the water cycle built again, we could reduce a lot of these weather-related issues. Okay. We're also going to get more sunlight harvesting. Okay. If we can manage the plants in a regenerative way, we're going to collect more sunlight throughout the season. If you picture a plant growing once and going to maturity, okay, we get one top growth, we get one root penetration, which means one set of exudation happening, and then once it matures, it's done. We might still have some summer left, but the plant's mature, it's done exudating. Doesn't put any more exudation into the soil. Now, if we could manage it regeneratively, bring some animals in and graze that once, what happens is that plant will grow, the root systems will dig down once, put out exudation, then the cattle come along and graze it once, preferably later stage 2, whenever you can. We slough off, or we graze off the top of the plant. The plant no longer needs this big extensive root system underneath, so it'll slough off some of the root system. So we'll get some added nutrients from the dying and decaying root system that's sloughed off. But then we'll get a second penetration of the root system from the growing plant again. We'll get a second set of exudation going into the soil with that second growth. So if we can have that, grazing and resting of regenerative agriculture, then we're going to get more carbon put into the soil. So that sunlight harvesting, we're going to get more of it. Nutrient recycling is also an important part of what we're going to get out of this. 97.5% comes from the air. That 2.5%, we need to recycle as much of it as possible. Okay? Even some of the 97.5, that nitrogen, I want to get in my system and recycle it. So with regenerative agriculture, a big part of what we're doing is trying not to export nutrients. Most of agriculture exports as much as they possibly can. That's what we're told to do. But if we can recycle more, we're going to be more sustainable, and we're not going to need the inputs, and then we're not going to be damaging to our biology. So recycling nutrients is important too. And of course, I've already said it, the biology. With regenerative grazing, we're going to start building biology and getting a whole bunch of these benefits. So I call these my 4 grazing principles. My goal is to improve all of these, improve the water cycling, improve the energy flow, which is the sunlight harvesting, improve nutrient recycling, and build more biology. That's my goal, right? That's the why. So let's look at the how. Real simple. We've got 4 grazing concepts that we need to deal with. You need to be able to manage this. If you have trouble remembering, look at the first letters. It's GRAS. It almost spells grass. So graze period, that's the amount of time that the animals are on a specific paddock. So little definitions here. If I've got a pasture, say it's 500 acres, I've got multiple paddocks in there. So I'll have a whole bunch of small fields in there. So my graze period is the amount of time on a particular paddock, not the whole pasture, just the particular paddock. So it might be, 1, 2, 3, 4 days that they're on that paddock. So that's my graze period. Now it also has to work with a rest period. That's the amount of time we're off of that particular paddock. So we've got multiple paddocks out there. So this is a graze and then let rest. If you picture one of these little paddocks, I treat it basically how we treat a hayfield, right? We get on there, and when everybody knows how to make good hay, you let it grow, go on there for 1 day and cut it down, harvest it off. Hopefully you get it harvested off in good condition, but then you let it rest and you let it grow again until that late stage 2, and then you're going to take your second cut. So in reality, that's all I do with my grazing is I'm trying to graze it quickly, just like the haybine would take that hay field off. And then I'm going to give it enough rest so that it can completely recover and get back into maybe late stage 2 before I harvest it again. The dilemma with grazing is we can't park our equipment in the shed for 2 months and wait for that to happen. So we need to have multiple fields and stagger them so that we can have a good graze period and a good rest period. So my minimum in my environment, it depends where you're from, but the environments are all different. My minimum in my environment is about 16 paddocks. To be able to have a short enough graze period, but still have a long enough rest period to make them work together, is I need about 16 paddocks. So a drier environment needs more, a wetter environment might need a few less. But in general, that's my rule of thumb. So graze period and rest period have to work together. The other 2 concepts are animal impact and stock density. Okay? Animal impact is the stimulation on the soil from the animals. Okay? I used to say that it was the stimulation of their hooves, but there's more to it than that. The stimulation of their hooves is the physical impact. It can break capped soil, that hoof hitting the soil. It can help recycle nutrients. It can cause seed to soil contact, get new plants to germinate. But the other side to animal impact is also the biology of it. There's biology and food for biology in the manure, biology and food for biology in the urine, and in the saliva and in the phlegm, and even biology falling off the hair coat. That there's symbiotic relationships between the animal's biology and the soil's biology. They need to work together. You don't get that from the haybine. Okay, that biological animal impact is very important in this situation. Stock density is kind of works with animal impact, is not the number of animals you have on the pasture for the whole year, but it's how many animals on a specific paddock for a given period of time. So it's kind of a snapshot in time. Let's say we have 100 animals on the pasture for the summer. That's stocking rate. If we have those 100 animals on one paddock for 2 days, now that's our stock density. It's basically how crowded up they get. The stock density is important for 2 main reasons. One is your even plant utilization. So when that haybine goes across the field, it cuts every plant. So every plant in the hayfield gets cut. So we need to get, when we're grazing, we want to get our stock density high enough so that in that 1 or 2 or 3 day graze period, whatever we're using, then we want every plant to be either grazed or stepped on or knocked down, right? A good plant utilization means everything's kind of knocked down at the end of the grazing. Okay, so the higher the stock density, the better the utilization. If you picture a continuous grazing where the animals just to get to go out there for the whole season, right? They graze all the really good plants, but then they leave a bunch of the undesirables. And we end up with these you know, a whole bunch of plants grazed right to the ground, and then a whole bunch of plants that are getting mature awns. So we don't want that. We want to make sure everything gets knocked down. That way we have an even playing field for everything to come back. Okay? The undesirables don't get the advantage, right? If they don't want to eat that thistle plant, well, it gets to live and survive and go to seed. It has all the advantage. Whereas if we can at least get them to step it to the ground, then the other desirable plants have a better chance of coming back. So that stock density is important. The other benefit to stock density is better manure distribution. Okay? The higher the stock density, the better the nutrients get spread around. And we're trying to recycle that nutrients. 80% of what goes into a cow comes out the back end. Okay? We talked about not exporting nutrients. That's the benefit of the herbivore, is 80% gets recycled. So we're only exporting 20% off of our land. Whereas in a grain operation, you're probably exporting 80 to 90% of your nutrients off of your land. In a hay operation, maybe, you know, 60, 70, 80% of your nutrients you're exporting off the land. So with a grazing operation, with regenerative grazing, you're only exporting about 20%. So the higher the stock density, the better that gets spread. In a continuous grazing situation, most of the manure ends up by the trees or by the water trough. So we're taking nutrients from the open field and we're spreading it into the trees or by the water trough, right? It's not a benefit. We're getting high concentrations in small areas. The higher the stock density, the better that gets spread around, and we get a better nutrient recycling that way. So that's a quick version of the grazing concepts. We need a short graze period, short enough so that we don't take the second bite. We get a nice even cut. We need a long rest period so that the plants can fully recover. We don't really want them to get mature, but we want them to fully recover and replenish the root reserves or the energy stores of the plant. Animal impact is important for biology, plus the stimulation on the soil. And stock density, that two benefits is the even plant utilization and the better manure distribution. Okay, so that's the how. Well, how do you do that? What do we need now? You just can't go out there and tell your cows to do that. So we need to manage them a little bit. So the how basically comes from simulating what nature used to do. Okay, back when the bison herds used to roam around, they're not really roaming there. It's just the only bison picture I have. They used to regeneratively graze. They would move around in small herds because of the predator. The predator would keep them scared, and they would basically run around. They'd all graze in a clump, in a big group, graze it down, soil it, like put all that manure in one area, and then there'd be no grass left, and they'd move on to another area, and they'd move on to another area. So they kept moving in these herds. And then we went and invented barbed wire in the 1800s, and we scared away the predator, and we started continuously grazing, which was one of the worst things we ever did in the livestock industry. We started damaging the soil, we started damaging the environment and the water cycle and all sorts of things. So what we need to do is go back and manage how nature used to. Okay, so what we need to do, the cheapest in my environment and in most environments, there's exceptions, but in a lot of environments, the easiest way to do it is with some electric fencing. So we're going to look at cell design now, how we manage to make these paddocks. I said I'm going to use 16 because that's kind of my magic number. I'll tell you right now, all of my pastures have more than 16 paddocks. That's a minimum. And in a lot of environments, you're going to need a lot more. That's when we start strip grazing and moving a fence, so you get more paddocks out of it. But we'll look at cell design here to try and manage it. Now, if some environments, if you got really big, range leases or large areas, herding can still help. Might be easier to, move the animals around on large areas than it is to put up a bunch of cross fencing. But in most of the farms that I deal with, electric fencing is the cheapest way to manage the cell or the herding. Okay, so we've got actually 5 different types of cell design. I've got one duplicated here, so that's why there's 6 pictures. But we've got a 2-alley system we're going to look at. We've got a 1-alley system. a water truck system, a pipeline system, a cell center system, or some people call it a wagon wheel or a pie, and we've got a strip grazing system. Okay? So a two-alley system. Basically, in this example, you can see the water at the bottom of the picture, and we've got an alleyway going up both sides, allowing the animals to walk back from each paddock down the alleyway to the water. So on a daily basis, they'd be walking back, depending which paddock they're in. Okay. The interior cross fencing. So just to compare apples to apples, all of these could be the same. They don't need to be this, they can be different sizes, and we could have the exact same cell design. If this piece of land was a quarter section, which is 160 acres, then we'd have 16 paddocks here. Each paddock would be 10 acres in size, and with 16 paddocks. Now, if this was a full section of land, which is 640 acres, so it's 4 times as big, so that'd be 4 quarters together, then we'd still have 16 paddocks. We could still have the exact same cell design, but each paddock would be 40 acres in size. So I don't want you to get hung up on the number of acres in a paddock, because that changes depending on the overall size of the whole cell. Okay. For this example, we're going to use 160 acres, which would mean 16 paddocks, and each paddock is 10 acres in size, just so that my calculations for the fencing works. So this example, a two-alley system, the interior fencing, that doesn't include the perimeter. The perimeter has 2 miles of cross fence, or a perimeter fence around the outside, but the interior cross fencing has 4 miles. Okay. In comparison, a one-alley system, a one-alley system actually has 4.4 miles of cross fencing on the interior. So a little bit more on the one-alley system than the two. Okay. Utilization is better on the closer your animals are to the water. So in comparison here, the square of the paddocks, the distance they have to get to this, the front of the paddock to the back of the paddock is quite short. So utilization will be pretty good. They will graze everything pretty evenly. In contrast, if we've got a long rectangular paddock like this, they may graze the front of the paddock more than they graze the back of the paddock. So we'll have a overutilization at the front, and we have underutilization at the back, depending on how intense you grazed. If you were to graze this in a day, it'd be pretty even. But if you were to graze this over, let's say, a 4-day graze period, you would have a utilization difference, the front to the back. Okay? So normally the squarer the paddock, the better the utilization. Okay? The downside with an alley system, the one or the two alley system, is that you end up with manure and urine in the alley. Okay? Your least productive piece of the land, and you're getting most of the nutrients there. So that's the downside to an alley system. Low labor, low capital cost. It's the cheapest one to get started, right? If you're just getting going on this and you got a cash flow issue to deal with, an alleyway is pretty cheap to put up. These, a 1-wire or even a 2-wire electric fence is pretty cheap to put up. The advantage of the alley system too is you can move animals, right? You've got that ability to move animals from any paddock to any paddock. You can bring animals in to treat a foot rot or anything like that. It's very handy to be able to have that alleyway to connect things together. Okay. So most of the details are the same with the one alley system. Low labor and capital costs again. Flexibility movement's the same. The one advantage I'd have on the one alley system over the two is if I ever want to bale graze close to, in one of these paddocks or a number of these paddocks, long rectangles are great to bale graze in. So if I think I might have the opportunity down the road to bale graze, I might purposely put a one alley system and make long rectangles. Really nice to strip graze down too if you want to, have 16 paddocks, but also maybe bump that up and get double that. You could strip graze each one once. Easy to strip graze a long rectangle. Okay, we got a water truck system. Now, some people love the water truck, some people hate it. It is less fencing, so three miles of cross fencing because there's no alleyway at all. Good utilization. We got those square paddocks in the perfect world. We know we're not always perfectly square, but you basically put your fences where you want them, and then you haul water to them. Excellent manure distribution. You don't even have a watering site that ends up with more manure. You can move that every time. So it really good for that. Increased capital and labor costs. You have to have the equipment, and you have to have the time and you put the energy into hauling water all the time. So it kind of depends on the size of your operation and your situation. I mean, for me to haul water to, let's say, a herd of 600 head, that's a lot of water to haul. On the contrast, I've got a small pasture pig operation where we have 20 to 30 to maybe 40 pigs at a time. There I got a small water tank that I haul water with, and I haul it maybe once, maybe twice a week. So not as big a deal in that situation. So everybody's farm is different. So that's why there's some different options here. So good utilization square, excellent manure distribution, you move them around. Yeah. Oh, increased herd effect or animal impact. You can basically place that water site on a problem area or somewhere where you want to stimulate some new growth. As long as you do it for a short period of time, it's actually quite beneficial to increase that animal impact. So can be good for that. But most people who don't like it, it's that increased capital and increased labor cost that is the biggest problem. The cell center system, or a pie or a wagon wheel. This is where everything radiates out from one location for the water. 4.8 miles of cross fencing in this example. So it's the most of all these examples. Those long diagonals really add up. Long paddocks, again, you can have poor utilization, just like the long rectangles. They're just long triangles this time. Manure distribution, same thing, can be negative, depending on how intense you are. Again, if you were to graze each paddock for a day, you wouldn't have, it would be pretty good. If you were to do 3 or 4 or 5 day rotation, then yeah, your utilization and your manure distribution would be worse. So, advantage is low labor, low capital costs. Animals do the work once you got it set up. Flexibility movement's pretty good. In this example, all the paddocks go to one water site, so you can move from any paddock to any paddock at any time. Okay. So that's the pie or the cell center. Pipeline system. Basically, you're running a pipeline so you can put your troughs wherever you want. Most convenient spot, design your fencing and put a water trough there. 3 miles of cross fencing again, good utilization, good manure distribution. Can be increased capital costs. That can put some money in, depending if you have a pumping system or not. If you've got your house is already on this piece of land, you've already got a pressure system, well then a pipeline running out somewhere might be the cheapest method because you don't have to buy a pump or any other part of that system. So, but can be expensive if you get it set up. You're gonna want to do this on some permanent pasture. I don't have very many pipelines because all of my land is rented. So if I lose a piece of land, I don't want to put a whole bunch of dollars into permanent infrastructure. So once it's set up, it's kind of nice. It's low labor costs. You basically open a gate and move the cows, and it's pretty easy to go. So a lot of people like the pipeline system. Strip grazing. Lots of variations in strip grazing. This can be lots of different options here. So we showed a few here. On the left-hand side with the blue running down, this would be a water pipeline as well, so kind of a combination here. And then you'd have multiple spigots along the way that you could attach a water trough to. So you'd probably have a movable trough, and you'd need a couple of strip grazing fences as well. So you'd move your way up one side, and you'd move a back fence with you, so you're only on that one paddock. You get that side, you'd basically come back down the other side. So the least amount of permanent fence, you've only got 1.5 miles of permanent cross fence, and then you've got these portable fences that you're moving. So variable utilization, and manure distribution. That can be very dependent on how intense you are. If you grazed really intense, it'd be really good. If you left them out there for 3 or 4 or 5 days in each paddock, then it wouldn't be as good. So again, depends on how intense you are. Much higher labor cost. I don't do a lot of strip grazing because the labor cost is quite high. You actually have to pay somebody to go out there and do that. You'll see how quickly that adds up. And I've got to make sure my margin works for my system. So Make sure you're including your labor and equipment costs when you're doing this. If I was in, South Africa or South America, or, a country where I could get very low labor costs, I would strip graze everything, right? I'd hire somebody to go out there and strip graze everything. But in my environment, I mean, you can't get somebody for under 20 bucks an hour that's any good, and they need a piece of equipment with them. So the labor costs can add up pretty high. Flexibility of paddock size is nice here. You can make some small paddocks to go across, maybe a weed patch you want to get some extra animal impact on. But maybe next weekend you want to go camping for the weekend, so you can make your paddocks bigger, so you can adjust the size of your paddocks quite easily. Low capital costs. Getting into this is pretty cheap. So we just need a few portable fences and some step-in posts, and you're good to go. On the right-hand side, we got a little bit of a variation here. The water is back down at the bottom, and then we've built, with temporary fencing, we've built 3 paddocks out of 1. So this is a long rectangle. We'll put 2 fences across. Let's say we have a 3-day graze period on this paddock. So for day 1, they go into the front piece and they graze it. On day 2, we take down the first fence, and now they walk through paddock 1 and graze paddock 2. And on day 3, we take down the second fence and they walk through 1 and 2 to get to 3. So what we have to maintain is the fact that we're off of that whole paddock within our desired graze period. So let's say our desired graze period was 3 days, then we have to be off of it before then. If you do that over a week, then you're going to end up overgrazing the first paddock or the first 2 paddocks. Now, what that did was, as long as we don't hurt our graze period and our rest period, what it did was increased our stock density and our animal impact. Okay, so we're going to increase those and get a little bit more stimulation out there. So it can really do quite a bit of benefit to that paddock. And on the far side here, we'd be just more intense. So this would be mob grazing, or we just move a fence multiple times a day and try and increase that stock density and animal impact. Okay? But they're going to walk through the first paddocks to get to the end. Again, the key is you've got to get through all of the paddocks before our plants start to regrow, before that desired graze period is too long. Okay? There's combinations. We can do strip grazing in a cell center. Okay, so we looked at the pie or the cell center. We can do that with temporary fencing. So here's an example. We've got a water site in the middle. So we put up 2 temporary fences, put the cattle in there, and then we put up a 3rd one. When they're done the first paddock, you have a roller on this middle fence. You roll it up a bit, allow the animals to move into the second paddock, put your fence back up, and then you take down the first fence and put it up over there. Okay, and then you do it again and again and again. Every time you need to move, you just take down the back fence and put it up in the front fence. So this is kind of handy. We can adjust the size of the paddocks here quite a bit. You can do a small paddock or a big paddock, just like the other ones, but we're just basically strip grazing in a cell center pattern. That's all. Same as the other one, but just a different variation of it. Okay. Combinations, here's alleyways with pipelines. Okay, we've got a water pipeline taken out to the middle here. We've got 4 of them. So lots of times when we first start, cash flow might be an issue. So we put in the alleyway because it's nice and cheap. And then as we, over a couple of years, we start getting some cash flow together, we can put in a pipeline and get that water closer to the animals. That way our utilization and everything gets better. I'd still keep the alleyway because it's an alleyway of convenience. You'd still get the benefit out of that alleyway, flexibility of movement, being able to bring an animal in if you needed to. So I would probably keep the alleyway of convenience. So there's all of them. Kind of a snapshot of all 6 that we just looked at. Like I said, we're trying to compare apples to apples here. They're all the same size. They're all perfect. There's no physical land restraints, right? We know that never happens though. So we can look at this in the real world. Okay. That was kind of a make-believe world. So we've got lots of different examples. I'm just going to show you a few. This is just a diagram of a paddock. The speckled black is trees, and you can see each paddock in there. The problem with this one though is we had a railway track going down the middle of the quarter at a diagonal. Okay, so this diagonal is a railway track. So a 2 alley system isn't really going to work in this. What I'm trying to show you is that every piece of land is different, and there's 6 different cell designs, or technically 5 different cell designs that, you know what, some of them won't work on this piece of land and some of them will work on this piece of land. So there's more than one way to do this, and every piece of land is different. I have all the cell designs on my property. So this is a half a cell center on this side of the railway track. Obviously we've got a nice pie there. Here we've got an old corral system. So these paddocks get fed out of the corral system. Kind of an alleyway right here, a short alleyway, but basically it's a cell center as well. So, but that railway track kind of messes things up. And the bush paddocks too, they feed back into this as well. Okay. Here's another one that I did some consulting on. It's not one of mine, but they had these shelter belts going down the middle of the field. It used to be a grain farm in Saskatchewan, and they had these trees all planted down in nice rows. So you don't want to take them out. So we actually set up a strip grazing system. Would a cell center or a pie work here? No, because you're trying to protect those trees. So like I said, every piece of land is different. So we would strip graze down this side, come back, down, come down this side, and then we'd pop across here and kind of do a rotation that way. This was actually started off to be a water truck. He was planning on using a water truck out here, and then when he got the cash flow together, he would put in the pipeline and then be able to have the water pushed out to all these paddocks and have multiple spigots all the way along where he could connect his trough to. So this was a strip grazing with a water truck and then progressed to a pipeline as well. So a little bit of everything on that one. This is one of mine, a little bit bigger. Each one of these blocks is actually a quarter section. So the gray is actually gravel roads. This black line over here is the highway. So we've got quite a rare variation here. We've got lots of bush in the back. A little bit of combination. Let's look at the top right first. This was actually a strip grazing in a cell center. I had to run fences, temporary fences on this 80 acres. He didn't want any permanent fencing out there, so this was all strip grazed. Top of the picture, there's a fairly heavy bush here. There was no water on this 80-acre piece, so I had to haul water. So this was a water truck. When I knew that when animals were in this one, I had to haul water to. Okay, the one below it, we've got an alley system connecting everything back to that water. Let's look at the far left. The water site here, hard to see the fences there, but basically this is a cell center that runs out of this watering site. The middle one, yes, this is a cell center as well that feeds most of these. There's actually an alleyway that runs here. You just can't see it on the picture. The back here, this water site here basically feeds all this bush. It is a cell center as well and feeds most of these bush. And then this water feeds this one. Okay, so a little bit of everything on that piece. This one is another one of ours. This is 1,700 acres. Again, a little bit of everything. We've got a cell center here. We've got an alley, a little bit of an alley system here. One of the big issues we have when we get bigger is animal movement. We actually have, look at this little connector piece. We actually have a fence running lengthwise across. It would have been cheaper to run a fence down this way, up and down. Would have been a shorter fence, but I ran it lengthwise because I got to plan my animal movement. So let's say I started grazing over here on the right. We'd graze around, come up here, graze this part, graze part of this. Then we cut across on just one of these, graze these top ones, and then come down this left-hand side. Then we got to come back on the right-hand side and then cut across on this other paddock to get back into our rotation. Okay, so we've got to plan that rotation in advance to make it so we can get back to where we started. We don't want to graze ourselves into a corner. This little piece at the bottom is actually about a mile down the road. We do a cattle drive a couple times a year back and forth into that one, just to add that into this one. It's too small to be run by itself on most years. So, okay, so that's another one. This is actually one my daughter did. Her job was to mow the lawn on our yard. And this was basically the yard around our house and our shop. So she designed the paddock layout, and she had to run the garden hoses and the water trough out, and she grazed a horse and 2 donkeys on this. So it doesn't really matter the size of your operation. We can go from 1,700 acres on this paddock, sorry, the 1,700 acres to 5 acres. And we're still using the same concepts, the same principles. We're still trying to manage the exact same manner. It's just fewer animals. And she did this with 16 paddocks, did a twice over rotation, and did a very good job at it. So this could be 5 acres or it could be 500 acres. It could be the same design. Obviously, our infrastructure would be a little bit different. If this was a 500 acre piece, though, that'd be a really big house and shop. I'm assuming you're going to chuckle at that a little bit. Okay. Physical land restraints are a big issue. Here's just a section of land. We've got open fields and we've got a lot of bush. Okay? A lot of people ask me all the time, how big do I make my paddocks? Well, the key to how big your paddocks are is how much production they give. Okay? As an example, the more productive the land is, the smaller the paddocks are going to be. Because I'd like to have a even number of grazing days, not necessarily even number of acres. Okay, so one paddock might be 10 acres in size and another one could be 100 acres in size. If they have the same grazing days, that's okay. Okay, so just an example, that's what the cell design looked like on this piece. So these big bush paddocks don't produce very much, so they can be a lot bigger. I still might only get 3 or 4 days of grazing out of them. Whereas some of these smaller ones are higher producing, I'll still get 3 or 4 days out of them. So I'm trying to make the paddocks the same size in grazing days, not in acres. Okay? Animal movement's important. We talked about that a little bit. Sometimes you can get caught. So if we were to graze this piece and we have, maybe 2 pieces that are kitty corner, graze paddock 1, 2, 3, 4, 5, 6. Oh, how do we get from 6 to 7? Okay, that's really awkward. So just maybe change your thinking a little bit, rotate your fences. Now we can do 1, 2, 3, 4, 5, 6, 7, 8. Really easy. I always try and aim my cross fences to my gate so I can go in one and back out, out one side and back in the other. So when I'm designing a pasture design, these are the things I look at. Personal restraints, everybody's a little bit different. Maybe you work, full-time job, you can't do a water truck. Herd restraints, maybe you got a heifer herd and a cow herd. Maybe you got a purebred herd, right? Your herd restraints are going to be a little bit different. Water location makes a big difference on where that, which system you're going to use. Maybe if it's right in the middle, maybe that cell center looks pretty good. If it's right in the corner, well, then maybe the pipeline looks good because you got to get that water out to the middle. So that's a big issue. Physical land restraints, we looked at trees in the way a railway track we saw. What about a river? What about lowland, right? You don't want to run an alleyway through lowland. They're going to punch it out. It's not going to work. So physical land restraints can vary which system you use. I like to separate out forage types. So open land from bushland, from riparian area, tame grasses from native grasses. I'd like to, bend those fences a little bit to match the terrain. Instead of running a fence straight across the paddock, I'd like to bend it to go around the low area so that we don't have that electric fence going through the really tall grass and shorting out. So I'll kind of keep those riparian areas separate. Speaking of riparian areas, we manage for them. A big part of my biology is because of my riparian areas. So I'll actually protect them and encourage riparian areas to, I don't want to drain the land. I want to build it and allow that water to sit because we need that riparian area. My actual water sources I protect, so I'll fence them and not let animals into them because I want to keep that water clean. Also for building biology, I want to keep that water nice and healthy so that we have insects and predators, beneficial predators to reproduce. Plan for animal movement, we talked about a little bit about the animal movement already. Convenience of winter management, again, if I can bale graze somewhere, I might select one system over another. Existing fence is last. Right, I want to look at it last. If I can utilize an existing fence, that's good. But if it's in the wrong place, it's in the wrong place, and I just want to run a new fence anyway. So that's my 10-step cell design. I think we're time for questions. Khalil, are you around still?
Yes, I'm around.
Okay, I think I'm going to quit there because we're running out of time if we want to save some questions. So if anybody has any, I'm on the Zoom webinar chat if you have any questions. Oh, the Q&A popped up. How do you estimate grazing days in a paddock? Basically, depends on your environment. You've got to, I mean, your eye is going to be your best tool eventually, but to begin with, that's pretty tough. Train yourself by, before you turn the animals in, guess how many animal days are out there. When you're done, you know, if you do this for a summer, every time you do it for some summer. When you're done, you calculate out how many grazing days you actually had. And if you do that every time for one summer, you're going to get pretty good at estimating with your eye how many animal days per acre are out in each paddock. When I'm starting in the season, early in the season, or I'm getting a new piece of land, I'm going to estimate the grazing days for the whole season. I've got to kind of budget on how many animals to bring in. So there I use a rule of thumb in my environment, which your environment might be different. I use a yearling per open acre, and we've got quite a bit of bush, so I kind of use it as a buffer. But if I've got a 500 acre paddock with 300 acres that are open, I'll plan to bring in about 300 yearlings. If that was cow-calf pairs I'd bring in, then I'd cut that in half. A yearling, 2 yearlings will eat about the same as a cow-calf pair. So in that case, 300 open acres, about 150 pair I'd bring in. And then we plan that for the season. No more questions?
No more questions. I haven't got any questions yet.
Okay. We've got a couple minutes. I could run through some of the equipment that I use if we've got a few minutes.
Okay.
Okay, we'll pop back to here. Step-in post. This is one of my favorite step-in posts, mostly for the wintertime, but it works really good in the summertime. The bottom's a little bit different. This is a PFI post that I use. I can actually tap that with a hammer, and it's got a pointed tip. The tips are pointed so they can go into the hard ground. So if you've got a really dry environment, or in the wintertime if it's frozen, this is a really handy post that I use. I like it from PFI. Insulators. I don't like insulators. I hate all the insulators. There's always something wrong. They're plastic, they're weak, it just doesn't work. I'm not a real big fan of insulators. My favorite insulator is actually no insulator. This one on the right here. It's pounded in a little tight there, but in my environment, because I don't get that much rain, we don't lose a lot of shock through that. If you're going to use an insulator, use a better quality one, or I like these triangular ones that you slide down the end of the wire. Then I've got a staple holding it on. We've got a lot of wildlife that like to pull off all these plastic insulators, so I want a 2-inch barb staple holding my wire onto a good solid post. Offsets, you got an old crappy barbed wire fence. I love doing offsets. So the top right one here is a proper, you purchased offset. These are a couple I've invented out of a water line. You just set it up like that, put the wire in that groove, it holds it off about 6 or 8 inches. And then you've got some house water line that I've done as well. So, rollers, I like these rollers because you can take them apart. A lot of people really like the geared rollers because they're faster, but boy, when they tangle up, boy, they're not faster. They take you forever to untangle. So I like these rollers because you can pop them apart if they get tangled, and they're pretty quick to use. Fencers, I use all sorts of fencers. There's a Gallagher, Stay Fix, Speedrite. My typical setup is I don't use a great big fencer. I'd rather power a smaller amount of fence with a small fencer. Less to check, get it going. So here's basically a solar 12-volt system. I've got a RV battery there. I just pick up my own solar panels, and then one of these fencers. Advantage of some of these fencers now is you can buy them that they're 110 volt or they're 12 volt. You just change the cord on the back. So I really like those. My favorite handle now, a gate handle, is a Zammer handle. Very useful. You can connect it to the plastic here so it doesn't conduct electricity, or you can attach it to the metal so it does conduct electricity. Same on this end. You can hook it to the fence so it does, or you can hook it on this plastic one so it doesn't conduct. So you can change how you're connecting there. I really like that. And really hard to break, right? I've broken so many gate handles over the years. This one is very solid. It's flat to the ground. You can run over it with your truck and it doesn't break it. So I really like it for that reason. This is a electric fence trainer. Just put a pop can and punch a hole in the bottom of it and run a piece of wire through it. Boy, if you want to train animals to electric fence quick, boy, put something shiny that waves in the wind in front of them, and boy, within 10 minutes, every nose has touched that. Best tool I have on the farm is probably a Smart Fix tester. Now, there's different companies that make them, the Stay Fix and everything. They're all similar, but this one happens to be a Gallagher. Saves you thousands of hours of time because it will tell you where the fault is in the fence. Very well worth getting the Smart Fix tester. Okay, that was real quick. Good to go. I haven't seen any more questions.
You got one question.
There you
Steve.
go. What does an ideal grazed paddock look like as opposed to an overgrazed one? Leave more residue. Leave as much residue as you can. Leave more than you think you should. If you think that it's time to move them, then you should have probably moved them yesterday. One of the biggest mistakes I made as a young grazer, if I could go back in 20 years and tell myself, one thing to improve is to leave more residue. So, there's a rule of thumb that's you take half, leave half. So let's say you've got 12 inches of growth out there. You might want to make sure when you leave, there's at least 6 inches still out there. Now that's a rule of thumb. In some paddocks, I only have 3 inches to begin with. So it's pretty hard to leave half of that. In those situations, maybe I need to leave all of it. Okay, or 80% of it to try and get that land healed because it's not doing very well, or it's a new piece that I'm taking over. And other pastures where I've got lots of residue, it's growing 2-3 feet tall. Leaving half of it is a waste of grazing. So if I leave 20% of it, then I've still got lots of residue out there left. So, but that take half, leave half is a good rule of thumb.
No more questions.
Doesn't look like it. Okay, well, we are pretty well out of time. Thank you, everybody, for showing up, and I hope you got something out of that. If you have any questions, don't hesitate. You can email me. I wouldn't advise you trying to phone me because I'm very hard to get a hold of on the phone. It sits in my truck and doesn't get answered very often. So email is the best way, or through my Facebook page, Greener Pastures Ranching. By all means, follow that, and we try and keep it as an educational page so that people can ask questions and learn lots on there as well. So by all means, you can follow me on Greener Pastures Ranching.
Thanks a lot, Steve, for your time, and thanks everybody for joining us today. Take care.
You said this is going to be online and available for other people?
Yes.
Yeah, excellent. So if you want to go back and you missed something, you can go back on the Battle River Research website or Facebook page. Where is it going to be?
It's going to be on the website.
Okay, excellent. Okay, well, thank you to everybody for attending tonight, and we'll see you again down the road sometime. God bless.
Thank you. God bless.